Well, this video is for the first project for Math 111, and it's based on ideas having to do with the golden ratio. So if we start with a line segment of length 1, now if we divide it in half so that each of these is length 1/2, then the ratio of the whole piece to this one is 2 to 1. It's twice as long. Okay? And the ratio of this one to this one is 1 to 1 because they're the same amount, they're the same length. Let's see, if we divide it into, let's say, thirds, so that this is 1/3 and this is 2/3, then the ratio of the whole thing to that longer piece is 3 to 2, and the ratio of the longer piece to the shorter piece is 2 to 1 because it's twice as long. And you can continue to do this. And so mathematicians or philosophers, who in ancient Greece were the same thing, kind of arrived at this question and said, where can we draw the line, okay, so that the ratio of the whole length to the longer piece is the same as the ratio of the longer piece to the smaller piece. Okay? And so we can set this up algebraically. If we call this length x, then this one over here will be 1 minus x, right? We just saw that when I was drawing over here, right? If this was 2/3, then this is 1/3, which is 1 minus 2/3, and so on. So if we want to, again, if we want to set something up mathematically or algebraically to represent the golden ratio, the statement of the golden ratio, where the ratio of the whole segment to the longer piece is the same as the ratio of the longer piece to the shorter piece, that's where we come up with this equation. The ratio of the whole thing to the longer piece, we want that to be the same as the ratio of the longer piece to the shorter piece. So that's what we're looking at in part 1 of the project. Now, to solve this equation, you would want to cross multiply and then apply methods that we've talked about relating to quadratic equations to solve that. Okay? If you want an example of how to go about doing this, section 1.9 on page 68 in the textbook goes through a process of how do we solve an equation like this using cross multiplication. So once you've done that and you've set up a quadratic equation, I'm asking you to do a couple things here. So, solve for x once you get that equation, both as a decimal approximation and an exact value. Okay? So, if you've got a quadratic equation that looks something like this, you can just run this through the quad program on your calculator, and that will give you the decimal approximations. Okay? To get an exact answer, you need to actually use the quadratic formula. Some people, in doing their projects, just skip that part, and as a result, they lose a substantial number of points. Okay? And so what I'm saying is, please don't skip that part. I understand that it's much easier to run this through the program on the calculator, and that is part of what I'm asking you to do. A lot of what I'm asking you to do is to demonstrate that you can use the quadratic formula for yourself. Okay? All right, so that'll give you the answers to a solution for this equation. And then I ask you to determine the value of the ratio 1 over x. So if you take these, so for one thing, if you look at this, if this length is 1, that means x has to be greater than 0. Okay, so we're not going to work with the negative answers that come out of the quadratic formula, whether it's coming from the calculator or whether you're calculating it yourself. We really just want the positive value out of this. Okay? Okay, so once we get those values, I also want to know what is 1 over x as a decimal approximation and what is 1 over x coming out of this thing as an exact value. Okay? One of the main things that I want students to do in completing this project is that if you get stuck, please ask questions. I'll be happy to talk to you about this project. But a lot of people, well, not a lot of people, a significant number of people just shy away from asking questions, and as a result, they don't get the correct answers and they don't do well on the project. Okay, so what I'm saying is, please, if you're stuck, ask questions. I would be happy to help you with this, and we have a lot of opportunities for you to ask questions. Okay, we have our weekly class meetings. I'm doing a Zoom math lab from 12 to 2, Tuesday to Friday. You can call and email me at any time, and if you want to come in person, you can set up an appointment. Okay, so there, like I said, there's lots of opportunities for you to ask questions. Okay, so this is part 1 of the project, and all this stuff that I'm talking about, the more you work on this yourself, hopefully the more it will make sense. Okay? All right. Now in part 2, we have another definition of the golden ratio. They said it's, people say it is the only number that is exactly 1 more than its reciprocal. Okay, so here's the golden ratio, here's its reciprocal, and we're saying that this number should be exactly 1 more than its reciprocal. Okay, now, again, if you want to solve this equation, you need to multiply on both sides by y. If you'd like to see an example for this in the textbook, section 1.9 on page 67, you can see this is the page right before the other example I was talking about. We'll show you how to solve something like this and go through the steps for multiplying on both sides by y. So then we would set this up as a quadratic equation. Okay. I'm not going to show you exactly what it's going to look like, but it will be in this format. And then the same thing. We want to go through and we want to solve this as a decimal approximation. Oh, I'll put y's in here. And also, we want to solve it as an exact value using the quadratic formula. Okay. Now, the key here is at the end of this, after you calculate these values, I want you to go back to part 1, take what you found as 1 over x, and show that it's the same thing as y. Okay? In part 1, when we solve for x, the ratio itself that we're interested in is the ratio of the whole segment to the longer piece, which will be the same as the ratio of the longer piece to the shorter piece. But this golden ratio that we're interested in is 1 over x. And so in part 1, when you solve for x, you need to go that extra step and say this is the golden ratio, 1 over x. In part 2, the value of y is the golden ratio, and then the last thing that I ask you to do in the project again is to show that y is the same as 1 over x, both as an approximate value and as an exact value. And again, if you have any questions while you're working through this, ask. I'll be happy to help you, okay? There's a lot of resources available to you, and I encourage you to take advantage of them. So, that's it for Project 1. We'll have a midterm coming up in a couple weeks and a second project after that, but we will worry about that when the time comes.